Hi everyone, and welcome to another video. This is Sam, and this is our third and final video in our demo series. And in this video we're going to talk about responding. So I'm going to take the role of an attacker. I'm going to create a few attacks and see how Sysdig is able to detect those attacks and how to stop them, and also we'll dig into some forensics around them. So let's get started. All right. In the previous two videos, the first one we talked about the building phase of your container lifecycle, and we talked about image scanning, how you can embed Sysdig in your CI/CD pipeline to ensure that your developers are running the applications with security in mind, shifting security to the left. The second video we talked about once you've launched your application in production, it's running. How do you monitor performance and act based on that? The third and last video, which is today's video, we're going to talk about responding specifically to security incidents. As I mentioned in the intro, I'm going to take the role of a hacker. I'm going to run some commands against the environment, and we'll see how Sysdig reacts. And basically, we're going to look at some of the forensics around that as well. All right, so let's get started. Okay, so I have my Sysdig console here, and I've got my terminal as well, and I'm going to run a few commands. Okay, so the first command, I am doing a kubectl apply for a YAML file that will basically create a privileged container, and then I'm going to exec into that container. Now that I'm inside this container, I'm going to run a few commands as well. First command, I'm creating a bash history file. Some containers don't have that, and I want to simulate, if you had a container that had this, or even if this is an attack on the host itself. Since Sysdig sits at the kernel level, we can see everything that's running on the host or inside of a container. So really, this could be a command that's run on the host itself. And in addition to adding a bash history file, I'm creating an nmap, or snooping around looking for. I could have been looking at an entire subnet, but for the sake of time, I'm just looking at one IP and one port, just to show you the command that's been run and how we're going to detect it. The next command is a grep, looking for any private key files that I might have here, and I did find one here. The next one is a copy command. I'm looking for, I already found the file that has the private key, but now I'm going to use a Python script to send that file using SCP to my hacking machine somewhere out in the cloud. Let me copy the last command here, which is basically shredding my bash history to cover my tracks after I'm done running these commands. All right, let's see what we've got here on the Sysdig front. Let's look at the last minute, see what has fired so far. Maybe look back at the last 10 minutes, wait until everything catches up. And there we go. So we see the 6 events that were created for the 6 commands that I ran. It all started off with that privileged container or privilege escalation that was created. And you can see the scope. This happened in the hipster namespace. There was no deployment. I just created a pod that's privileged, and the name of the pod was Nginx privileged. I know what host this was run in on, and I also know what the image was and the container ID. And then you can also see any commands that were run over here, right? It was just a command to run the container, right? You can also see the next command that I ran, and I basically attached myself to that container. So I exec'd into that container, did a terminal shell in that container. So pretty much the same things that we saw earlier. In addition to that, I can always go and take a look at the commands that were run, and I have the entire list of commands that I ran. So from creating the bash history file, the nmap command, the grep command, and if I click on any of these, it can show me more information, such as my shell ID, the process ID that was running, what the container name again was, and a few more information, what the working directory was, and so on. Here's my copy command, my Python command, and shredding the bash history. Let's go back to the policy events that we saw earlier. The next one was launching a suspicious network tool in the container. That's nmap. And you can see the command right here at the bottom. Searching for private keys or passwords. The exfiltration attempt. And I also attached a capture to this, and we'll dig into the capture file in a second. And then finally, the delete the bash history command that was run. So now let's take a look, because I created this capture file. When this exfiltration attempt happens, build a capture file for me and store it, and I can open this with Sysdig inspect. And let's take a look at what exactly we caught. First things first, let's look at the secure notification that was issued. And in the policy that I built, I said, give me 10 seconds before the incident and 20 seconds after, for a total of 30 seconds worth of capture. So the Sysdig inspect is also, as I mentioned before, laid out in columns for the different things that you want to do. In our case, we want to look at the security column. And if you look at the security column, you can look at things like the executed commands, when these commands were executed, on the time scale at the bottom. But of interest to me here is this SSH connections. If you notice, the SSH connection just happened prior to firing the alert or firing the trigger. And this is where I sent out that private key file outbound to my machine out in the cloud. So I can also look at the files that were accessed. But first, let's take a look at the SSH attempt. And from here, we can see exactly what IP on the client side and what IP on the server side was accessed. So I have the IP address of the public facing machine, and it's on port 22, which is interesting. So going back, let's take a look at the accessed files. And I can see every single file that was accessed during this time. Now I can narrow this a little bit to just look at it 2.5 seconds worth. And I know from my commands that I saw earlier what exactly was accessed, right? So I can see this throwaway.pem file. So I can go back here and search for that. Here it is. And from here, I want to see what was the content of this particular file. And as you can see, it's totally a private key file. All right, so now I know what that file was. The second command that was run was this python app connect.py. All right, so let's go and find out what that file was. Connect. There it is. Let's dig into the contents of this file, see exactly what the attacker was trying to do. If you notice here, it's a Python script, of course, and at the very bottom you can see it's doing SCP put, so it's doing a secure copy. I can see the host name, where it's going to, what user was used, and so on. Basically, it's capturing this file and sending it to a file on a remote machine, and that myfile.txt was the file that was copied in the previous command. So I copied the throwaway PIM into myfile.txt, and I sent it over the network to this machine in the cloud. I have the IP address, I have the actual host name, and I know exactly what happened in this security incident. Now, you might be asking, well, this is all good. We see all the forensics. This is really deep stuff that we're able to see all this stuff. One thing to add is that containers are ephemeral in nature. So having this ability to store, what happened to the container is essential in a microservices world, because you might not know what happened. The orchestrator Kubernetes could have destroyed this container and respawned somewhere else, or could just disappear. So even if the hacker didn't delete their bash history, this container could be long gone. But with Sysdig Secure, you're able to capture all this information and send it to the backend so you can look through it later. Now, one last thing, you might be asking, well, okay, Sam, this is great stuff, but I don't want to reach this point where my data got exfiltrated. I want to stop the attack when I can. And that definitely can be done through the policies that we looked at here. And let me search the MITRE policies. And in here, you can see the exfiltrated attempt policy. You can do a couple of things. You can just kill the container. All I'm doing here, I'm just notifying, but I can kill the container right away when I see an attempt to exfiltrate data. But in reality, I want to do this before this step. So maybe I'm going to allow someone to run a privileged container. Okay, that's fine, which really is kind of iffy, but definitely I'm not going to let somebody do a terminal shell in a container in my production environment. So in the definition of my policy, I can scope this and say, okay, filter only for my production clusters, for example. And if I find somebody doing a terminal shell in a container in a production cluster, instead of notifying, let's kill the container right away. Or even we can pause the container and just quarantine it for further analysis. But definitely I would stop the container at the very least, and we'll stop the attacker in their tracks right from the beginning. So hopefully this has been helpful. And one last thing I wanted to mention, I promised that I would put this in the notes. This is the MITRE attack matrix. Here's the link at the top. I'll also add it in the description of this video. But basically, this is what the framework that an attacker would typically do. So some things like, if you're doing exfiltration, what would you do? Data compressed, data encrypted, a few things that you would do to exfiltrate that data, maybe over command and control channel and so on. What we did at Sysdig is we created this blog, and in this blog we have a mapping. You can see the Falco rules that we created that map to the different pieces of the MITRE attack matrix. I only chose 6 out of all of these to show in the demo today, but you can obviously use any of these. These are all created for you and accessible from our rules editor here. You can view all the rules that have been created. Just search for MITRE. Actually, if you search right in here, MITRE, you start seeing that we've tagged these. So this allowed SSH connection, for example. This is a MITRE remote service attack that you would probably want to look at, and so on. And you can reference these rules right from our policies engine. So you can create your own policy or use some of the policies already created for you. All right, well, hopefully you enjoyed this video and learned something new. Learned a little bit about the MITRE attack framework, what that looks like, and how Sysdig Secure can help you in an incident that might occur, how you can find every single command that might have been issued against your environment, whether on a host or inside of a container, how to prevent that from happening using the Falco rules that we talked about, and how you can stop a container or kill a container right from the beginning. Or if you didn't do that, then you can look through the forensics and find out what they've done and take action to mitigate any future attacks that might occur. Thank you once again, and I'll catch you in another video.